All right, welcome back to MM&M, Matt's Math and More. Although I never ever do anything more, it's just math. But anyway, today we're going to look at doubling volume. You can be done, no problems. If you're working along with math expressions, it would correspond with lesson 8-12 and homework 8-12. If you're not working with math expressions, it would be the concept of doubling volume. Don't worry, it's not that hard. It's hard, but it's not that hard. It's not like you're running across a busy New York street or anything. All right, so now let's take a look at volume. We know that volume equals length times width times height. And let's pretend, I don't know, you have a fish tank. And I'm telling you the volume of the fish tank is 8 gallons cubed. But I'm not telling you the length, the width, or the height. So you got to kind of come up with that on your own. You got to make something up. Well, really, you're just looking for three factors, factor, that have a product of 8. I guess I could think of it. I could go, I could do 4 times 2 times 1. So it's 4, 2, 1. Okay, yeah, because 4 times 2 is 8. So volume equals 8 times 1, and 8 times 1 is 8, so volume equals 8. Did I get it to equal 8 gallons? Yeah, I sure did. 4, 2, and 1. I guess there's other combinations I could try too to get to 8. I could do volume equals, let's see, length times width times height. What if I did, let's see, 2 times 2 is 4 times 2. Oh, I can get 8 this way. Yeah, because I could do volume equals 2 times 2 is 4 times 2 is 8. 8. So this is gallons cubed, gallons cubed. There's other combinations too. 8 times 1 times 1. I don't know. You could use other combinations if you like. All right, now let's pretend you really got into this fish tank and you're loving it. You decide you're going to upgrade. You're going to get a larger fish tank. And you want to get one that's double the length, double the width, and double the height. I'm doubling all 3 of these factors. Does that mean that my new volume is going to be 16? Because if you double 8, that's 16. No, it does not mean that. That's not how it works. What we're doing is doubling the length, the width, and the height. But you're going to see something cool. The cool thing you're going to see is that it doesn't matter if we use this one, 2 times 2 times 2, this one, or 4 times 2 times 1, that one. You're going to see something very interesting with both of them. Watch this. Let's pretend we're getting our new fish tank. And we're doubling the length, the width, and the height. Let's use this one, for example, 4, 2, and 1. So the new one's going to be 8, 4, 2. 8 times 4 times 2. I just doubled the length, doubled the width, doubled the height. Well, when we do volume 8 times 4, that is 32 times 2. And then 32 times 2 is 64 gallons cubed. So when I doubled the length, the width, and the height, I got 64 gallons. So it didn't turn this into 16, turned it into 64. Quite a big jump when you're using cubic volume. Let's check it out. Let's pretend you didn't use 8 times 4 times 2. Let's pretend you used 2 times 2 times 2. Check this out. Volume equals length times width times height. So instead of 2 times 2 times 2, I'm doubling it. So it's going to be 4 times 4 times 4. I just doubled the length, width, and height. And volume equals, okay, we got 16 times 4. Oh, which way? 16 times 2 is 32. I know that one by heart. And 32 twice is 64. Look at that. Gallons cubed. So either way, we came up with 64. So from the original problem where I just had the volume, I kind of took a few steps. I made up my products, my factors, and just forced them to equal the product of 8. 4, 2, and 1, or 2, 2, and 2. It didn't matter. I was able to make them up to equal 8 because that was what I was given, 8. Then I doubled them all, and came up with 64. It didn't matter which three factors I started with. In the end, you're still going to come up with 64. Drop the pencil. Ooh, running across a busy New York street.